243, the last one, and I thought rather interesting. And they start off with a liquid compound. Somebody discovered that it's 18% carbon, 2.26% hydrogen, 79.7% chlorine. And I know right away that I'm going to have to use the AMUs for carbon, hydrogen, and chlorine, and I'm going to use my little model to go from grams to moles, just like I did before. So my conversion factor will be moles divided by the AMU in grams for each atom, each element, okay? And again, we're going to assume 100 grams. We do this in every problem. 100 gram sample of this stuff. And so you can take some shortcuts as you write this down, but just make sure that you include all the information that you need in the problem. Don't just put numbers down and expect to get anywhere, okay? So I've got 18 grams of carbon rather, and we know that the atomic mass units of carbon is 12.01. So if I divide this out, I get the number of moles in carbon. Same way with 2.26 grams of hydrogen divided by 1.008, you know, so I'm going to have 2.2 moles down here, and here's my results down here. 1.5, you know, you can round this off at 1.5. Okay, I hope I can finish this up. And chlorine is 2.248. And then once you get that in, you can put it in the place where your subscript is going to go, and then you've got to divide by the smallest number. And I end up with a 1 for carbon. And look at, I'm going to put this in the fraction terms because I can do something with that afterwards. So 2.242 divided by the smallest number is going to be 1.5, and the same thing with this chlorine, it's 1.5. And I notice I got to make these all units, whole numbers, and I can do that by multiplying through by 2, and then so I end up with 2 carbons, and 2 times 1.5 is 3 hydrogen, and 3 chlorine, and that's it. And the last thing they ask you to do is to verify it. Just round these numbers off. 2 times 12 is 24 divided by the total. I get 18%, 2.2%, and 79%, which agrees with my original statement. So there you have it. So good luck, and finish the other 3.